Alright, so in this video we're going to look at discontinuous forcing functions. Basically, what these are is it just takes what we've learned all throughout the previous Laplace and just puts it all together into some pretty long problems. These are pretty long problems. These can be lengthy, so I only have 3 examples because of that. Originally, I was going to do 8 examples, all 8 problems, but that would have been like a 3-hour video probably. So I just stuck to 3. I'm kind of gonna go through these kind of fast because there's no really any new topics in this. It's more so just, you know, doing them. So I recommend go ahead, try it, and then play the video, watch me go through it, then see if you got it right. So I'm gonna go through kind of fast. So let's see. First things first, part A, it says to sketch the graph of the forcing function. I'm going to put it over here. The forcing function is this f of t here. So to sketch this, it'll be 1 from 0 to 3 pi. I'll just say 3 pi is there. This is 1, and then it's 0. This is closed at 1. Pretty simple graph. Part B, find the solution of the given initial value problem. So what we have to do is we have to rewrite our f of t. So let's see. If we use the first method, which I demonstrated in the previous videos, we look at the jumps. We're going from 1 to at 3 pi, we go down to 0, so minus 3 pi of t. Now I gotta put up my solution up here so I can see. Make sure I'm doing it right. Make sure my graph's good, yep. Let me make sure this is good, yep, okay. If I were to do the other method, we'd have 1 times u of 0 of t minus 1 times u of 3 of t minus 0 times u of 3 of t. Obviously, zeros cancel out. U of 0 is 1. So then f of t is definitely 1 minus u 3 pi of t. So let's put it all together now. So we have this equation. It's a second order differential equation. We want to solve for y by itself, y of t, right? It's a function of time. You can think of it as a function of time. Right now it's ugly. It's a second order differential equation, and we want to reduce it to an equation that's easy to solve. So what we're going to do is we're going to take the Laplace of this. So we have f squared. Take the Laplace, and then we take the Laplace again to go back. Because we want to take the Laplace, we go into f of s world, or y, in this case y of s world. Then we need to take the Laplace of that again. We simplify the Laplace, and we take it again, and we get a nice equation to end up in the end. And we can simplify, and it will be much easier to solve than what we currently have. So I'm just gonna go ahead and run through this. This is all stuff you should know by now. Nothing so far is really new. It's just putting it all together. Oh, if I take the Laplace of 1, that's 1 over s. This would be, oh, what would that be? E to the minus 3 pi of s. Our parent function for this one is 1. So 1 is 1 over s. That's our f of s, right? So now let's group these together. Um, 0 and 1. So this is 0. That's 1. So then y of s is equal to 1 over s times s squared plus 1 minus 3 pi s over s. Oh, the whole thing over s. That looks weird. Yeah. Times s squared plus 1 over s squared plus 1. We only have to do partial fraction decomp for just one of them, just for the 1 over s times s squared plus 1, right? This would be, so that's a s squared plus a plus b s squared plus cs. I distributed. Right, none of this stuff is new, so just try it and go through it. Do it your own work by yourself and then match it with mine, because I'm kind of skipping steps here, right? You can tell. If you have questions with any of this stuff, you can go back into my previous few videos. Anyways, 1 is equal to a, 0 is equal to c. Well, that's nice. And 0 is equal to a plus b. B would then be -1. So, since we did it for this first term here, y of s is equal to 1 over s plus b is -1, so minus s over s squared plus 1. C is 0. And we have this minus e -3 pi s times the exact same thing. So what, that would be positive then? Let me look at my... Yeah, that would be positive. Right, because we have this negative and we have that negative. So it becomes positive. Well, it's negative... it's negative e... And then I'll just rewrite what's... Yeah. Then we have plus that last term, which was... We didn't have to do any partial fraction decomp for that term, right? That's already in this form for sine. So now we need to find y of t, right? Y of t is equal to... That's just 1. This would be cosine of t, so minus cosine of t. Now remember that this one here is that funky one with the f of s. So you have to look at so when we replace t, we're just gonna replace t with t minus 3 pi, right? The f of t minus c. So then this would be u of 3 pi of t times 1 over s is 1. That is cosine of t, but it's t minus 3. And then we have plus cosine of t. Is that it? Oh, that's not... Oh, wait, no, because that's a 1 on top. That is this one, which... Oh, no, not that one. This one, which is sine of t. All right. That looks correct so far, yes. Can we see? Yes, we can simplify this. So 1 minus cosine of t minus u to the 3 pi of t. That's a 3 pi. Because t minus 3 pi is equal to cosine of t. Well, negative cosine of t, right? If it was minus 2 pi, well, Yeah, because cosine of pi is what? Is that -1? Let me think. Where's pi? 0, pi. Yeah, that's -1. So that's why the sign flips. So then we'll have 1 plus cosine of t. This is still plus sine of t. Can we go any further? I don't think so. This is the answer. Yeah, that would be the answer. Okay, that's not too bad. Let's look at the number 3 now. They're going to get progressively longer as we go on. I skipped one of them because I was going to do number 5 as well, but it had really ugly fractions, and I just didn't feel like dealing with those numbers. It was just an annoying problem. It wasn't necessarily long, it's really ugly numbers, so I just skipped it. It's really the same thing as we've been doing. But number 3, let me pull up my notes. So we're going to start with the graph, right? So let's start. This one we have to start by writing out our f of t. That's what I usually do. I usually always write out the f of t before I graph. You don't have to, though. You don't have to. But this starts with sine of t. And then, oh, this is nice. Sine of t, and we go down by sine of t minus 2 pi. This is sine of t. Because remember, sine of pi is 0, right? Well, that doesn't help us, but that's equal to sine of t. It's the same thing as sine of t. And I can prove that by, like, if you, let's say, plug in a 0 in for t, sine of 0 is 0, sine of negative 2 pi is 0, that's 0 minus 0. Say we plug in a pi, sine of pi is 0, sine of negative pi is 0, 0 minus 0. Say we plug in a pi over 2, sine of pi over 2 is 1, pi over 2 minus 2 pi, what is that? That's 3 pi over 2, right? Negative 3 pi over 2, which is equal to pi over 2, by the way. That's just 1 minus 1, which is 0, right? So no matter what you plug in for t, it would always be the same thing. You can then rewrite this to be sine of t, so then that's 0. This is when we're at greater than 0, less than, greater than, just less than 2 pi. Once again, if you don't understand any of this, you have to go back to my previous videos. These problems are long, so I'm going through them fast. Just greater than 2 pi, and then less than infinity. If we are to graph this, sine of t looks like 0, pi over 2, pi, let me do that in red. 0, pi over 2, pi, 3 pi over 2, 0. Oh no, 2 pi, or 0, goes back to 0. And then after 2 pi, it is just 0 onwards. Right, so 0, pi over 2. You can write at the intervals like this if you wish. Pi, 3 pi over 2, and then 2 pi, and then it's 0. So then part B, oh look, I already have it here. I did it before. We now have to solve it. So this isn't too bad. It's like kind of the same thing we did before in the last one. Let me just go ahead and do this. Oh, I forgot this. Oh man, sine of t would be And we have 1 over s squared plus 1 minus our parent function sine of t. That would be 1 over s squared plus 1 times e to the minus 2. See, I don't even have to look at the table anymore. I'm just starting to memorize this just from doing the videos. Isn't that amazing? I didn't even look at the table for those. Oh, I did for the sine. Is this correct? Before I go on, let me double check my work. 1 over s squared plus 1 minus e to the negative 2 pi s over s squared plus 1. Yes, we're good. Let's combine. Both of these are 0. Very nice. S squared plus 4. You don't have to do this step. You can kind of skip that. I don't know why I wrote all that out. But this is just... You got to really get efficient with these for exams and whatnot. Efficiency is key. Being able to do stuff in your head flawlessly saves you so much time. Like once you get good at it, it's all just algebra, but it saves you so much time. It all comes down to algebra. Algebra is where all the time is. DFQ is the easy part. It's algebra that's the hard part. That's always been the case for calc and whatnot. So we only have to do partial fractions for one section here. So that we'll have 1 is equal to, I'm going to skip a step. AS plus B times s squared plus 4. Actually, let me write it out. Just because for later, it could be useful to see this step. What are we? ABC over s squared plus 4. Now I can go to the step I was at. S squared plus 4. So I'm writing really fast. My handwriting's kind of going down the drain. So let's go ahead and distribute as cubed. FOIL plus 4as plus bs squared plus 4b plus cs cubed plus cs plus ds squared plus d. 0 is equal to a plus c. 0 is equal to b plus d. 0 is equal to 4a plus c. 1 is equal to 4b plus d. A is equal to negative c. 0 is equal to negative 4c plus c. Oh, c is just equal to 0. If c is equal to 0, a is equal to 0. Then we have our b's and d's. So b is equal to negative d. 1 is equal to negative 4d plus d. Negative 1/3 is equal to d. If d is equal to that, b is the opposite, 1/3. So that's the first part of our y sub s. So we can just go ahead and write all of that out. So we got, which ones are 0? The c and a, right? So those s terms will disappear. We have b over s squared plus 1. I'll just take out that. I'll take out the 1/3 out of the whole thing. Why not? We have minus d. D is negative. Same thing. This is plus 4, right? Yeah, s squared plus 4. I already see we have to rewrite this second one, right? But anyways, let's go ahead and write down the other half. What would be e to the negative, take out the 1/3. And this is the exact, is that right? Yeah, it's the same exact thing on the inside. So now I'm going to go ahead and just copy this down. Oh, hold on. Going to copy that, paste. Where'd it go? Paste. Going to rewrite these two because if you can see, we cannot. That 4 there does not the 1 corresponds with the 1. The 4 has to correspond with. That has to be rewritten as 2 squared. This has to be 2, meaning we have to divide by 1/2. Right? Another one of the techniques that we used in the original inverse Laplace video. So we're basically taking the inverse Laplace right now. Yeah, that's what we're going to do. Where was I? That's a 2, right? Yeah. 2. Okay, so now we could take the Laplace. So we have y of t, I mean the inverse Laplace. This would be, that's cosine, right? No, that's sine. So that's sine of t minus 1/2. That's sine of 2t. So other half's going to be the same thing, except we have this u of 2 pi. And then we have to follow by the f of t minus 2 pi thing. So we're going to have sine of t minus 2 pi, and I'm out of space, minus 1/2 sine 2 times t minus 2 pi. Bam. That's a u, by the way. Can we simplify? Yes. Remember, sine of t minus 2 pi is equal to sine of t. Just going to rewrite all of this. I'm absolutely speedrunning this right now. I'm sorry if I'm going too fast, but... sine of t minus... How can I rewrite that? That's sine of 2t, right? Minus 1/2 sine of... Minus 1/2 sine of 2t. Oh, look at that. This and this match. So we can pull out... Oh, so do these. So we can pull that out. 1/3... And it shrunk. 1/3 sine of t minus 1/2 sine of 2t times 1 minus 1/3. No, minus just u2 pi of t. I took out the 1/3. Phew. Where's the answer? Yeah. That's correct. I mean, you could get rid of the fraction on the inside there, but this is good enough. Yeah, that's correct. Okay, we have one more example. Number 7 here. This one doesn't look too bad. It's more the same exact thing, right? So this is the last one I'll do. You get the idea. Let's go ahead and write out our f of t. We start at this one's weird, isn't it? Let me go ahead and open up my solution so I don't make any mistakes. Yeah, okay, that's what I thought. So let me think about this. Oh, this one's weird. So we start at 0, right? There's a 0 plus in there. We start at 0. We go up to 1. And then we go down 1. Okay, oh, this isn't too bad. This isn't too bad. This is when it's greater than or equal to 0. Oh yeah, this is easy. Less than pi. This is between pi and 3 pi. And this is everything greater than 3 pi. Oh yeah, that's not too bad. This is an easy graph too. Starts at 0, goes up to 1, goes back down to 0. This is open, this is closed, this is open, this is closed, this is keeps going. This is pi, this is 3 pi, this is 1. So this is all you really need for your graph. If you want to get specific with your bounds, this is t, this is I guess f of t, or yeah, f of t. Okay, part B. It keeps doing that. There it is. Part B. We have to rewrite our f of t. Well, actually, no, we don't. Let's go ahead and take the Laplace. No, minus. Plus 4 times y of s is equal to, that is e to the minus, parent functions are 1 over s for both of them. Minus pi of s, e to the minus 3 pi of s. Let me double check. Yes, we are cooking. That's perfect. Both are 0 yet again. We like to see that. So I'm just gonna go right ahead. Go to the next part. So another partial fraction decomp. And you can actually simplify the partial fraction decomp for this one. And just, I'll show you what I mean by that. I'm thinking ahead here. You can look at just 1 over s times s squared plus 4. You can worry about the e to the pi is whatever later. A over s plus bs plus c over s squared plus 4. This would be a s squared plus 4a plus bs squared plus c. This is just like one we did before, isn't it? Yeah, this is really similar to the first problem we did. 1 is equal to 4a, that's it. That's it, yeah. 0 is equal to a plus b, and 0 is equal to c. A is equal to 1/4. If a is 1/4, b is negative 1/4. C is 0. Let's go ahead and write that out then. C is 0, so we only have to worry about... Well, first of all, we have the e to the minus pi s. So let's go ahead. Minus pi s. Let's pull out the 1/4. This would be just 1 over s. So okay, so then we can just do this. Easy enough, right? And then the second... No, let me do this. Because I forgot we have that other term still. So plus b over... No, what's b? So that'd be minus s over s squared plus 4. We do the same thing for the other one. We just take out this instead. What was it, 3? Yeah, 3 pi s. Same thing on the inside. That is a 4 and that is a 2. That's an S, right? Yeah. Okay, let me just check this, make sure this is correct. Where is it? Oh, down here. 1 over 4. Yeah, they wrote it differently, but yeah, same thing. Okay, so we're gonna have to replace our t for both of these. This first one would be f of t minus pi. This is u to pi of t over 4. 1 over s is 1 minus, that would be cosine. Our a would be 2, so I can, that's 2 squared, right? So that's cosine of 2t times u pi of t minus u to the 3. Let me just put that on the next line. I'm writing too big. U 3 pi of t over 4 times, sorry, that's not t, is it? That's cosine of 2 times t, in this case is t minus pi. My bad. 1 minus, plugging in t minus 3 pi. Both are the same thing, by the way, which is nice, so you can simplify it nicely. We can pull out, both of these are equal to 1 minus cosine of 2t, right? That's equal to cosine of 2t. Cosine of t minus pi is equal to cosine of t. So we can pull that out. We can also pull out a 1/4, so 1 minus cosine of 2t times u to the pi of t minus u to the 3 pi of t. They wrote it differently, but what's what I have over here, actually? Yeah, that's good. They didn't simplify it as much as I did. That's why. Yeah, this is good though. This is correct. I believe that was the last one. I did that in 30 minutes. I'd say that's pretty good. Yeah, that was the last one I have. They're all pretty much the same thing. Let me look at if there's any other cases really quick. No, there's no other cases really. It's all like doing the same thing over and over again for each of these problems. Just your f of t just changes a bit. That's all. But it's all the same process for pretty much all of them. You can kind of see they're all nothing, no really surprises between the 3 of those. And I'm looking at the other 4, and there's nothing that's gonna be surprising. So that's it. I mean, I remember, oh my god, the one exam my professor gave us, it was one of these problems, and the answer, first of all, it wasn't just our f of t. It wasn't just 2 things. It was like 4 or 5. So we had, right, like number 1 here, they can only give you 2. We had f of t. It was like 5. It was like 5 subintervals. Oh my, it was so evil. You can imagine, like, we only had 2 terms over here for all of these, really. Imagine 5. And they weren't nice. So you had to keep track of all 5. These are only dealt with 2 terms. Every one of these. That's more than double. So you can imagine the answer was this, like probably the whole second half of this page here, right? That's the kind of problems I had to deal with for exams. So that's why I'm so good at these and I can do them so fast, because of that. So it's really just a matter of practicing, you know. And in the next video, I think we're looking at impulse. Let me see. Yeah, in the next video, we're looking at impulse. Those problems are a lot quicker to do than these ones. That section won't take as long as this one. That's just deals with the Dirac delta. We're gonna look at these. We're not gonna look at convolution. My professor did not go over convolution with us, but we're gonna look at the Dirac delta function, which is this one right here, in the next video, which is a lot of fun. Dirac delta. With impulse, if you've ever taken physics before or dynamics, you've dealt with impulse before, and you might be able to see the connection. So I'll go over that in the next video, so I will see you then.